Hey guys, so here's the second part to the video. So now I want you guys to try the next quadratic regression on your own. So you'll see the coast downtime y for a car is as drops 10 miles per hour from initial speed x depends on several factors such as average drag, tire pressure, and whether the transmission is in neutral. Now the table below gives coast time in seconds for a car under standard conditions for the selected speeds. So what I would like you guys to do, so you'll see you have this table on your notes. If you kind of go over, you have A, B, and C. So what I would like you guys to do is go ahead and pause the video and go ahead and try A, B, and C on your own. So go ahead and do that for me, please. Okay, let's see how you did. So going back to our table here, notice it says that initial speed of x. So initial speed, since that's x, that's going to be your L1. And then it says that for our coast time, that's y. So that's going to be your L2. So remember, x values are always L1, y is L2. So they already given you the values. So we go ahead and plug that into our table. So remember, now I'm going to go a little bit faster here because we should know how to use our graphing calculator to do this. So remember, we go to Stat, we're going to Edit. So press Enter. Now, I'm going to go over and highlight L1, press Clear, and Enter, and then plug in all the L1 values. Don't forget, after each value, you press Enter. So like, for example, I'll do 40, Enter, and then it goes in. Okay, so now I need to do the same thing. So I'm going to go up to L2, make sure it's highlighted, press Clear, and then Enter. Now plug in your L2 values. So notice that I have the same amount of my L1 and L2. Now I'm going to go over to Stat, go over to Calculate, and then go to number 5, Quad Reg. Make sure your X list is L1, Y list is L2. Scroll all the way down to Calculate and press Enter. And here we get our A values. Now in part A, it does say round to 3 decimal places as needed. It is in the instructions for part A of your notes. So for our A value, we have 0.007. B is going to be negative 1.124, and then 57.964. So let's go ahead and write that for our part A of this problem. So they already give us our g of x, so we're just using our values. And once again, it told you here that we round to 3 decimal places, so read the instructions carefully. Now it says, using your model from part A, what would be the coast time for 70? So 70, that is our x value because that is our initial speed because it is in miles per hour. Now you might be wondering, well, how do I know that's my x value? Well, let's go back to our table. Notice when we set our x, it's in miles per hour. That's our initial speed. So since they gave us 70 and that's in miles per hour, that's our x value. So plugging that in, I have 0.007, and then I do 70. So every place I see x, I'm going to plug 70. So minus 1.124 times 70, then plus 57.964. Now remember, all you got to do is take this whole thing and plug it into your calculator. So I have 0.007, then I have 70 squared, then minus 1.124 times 70, and then our plus 57.964. And then you press Enter. And so we get about 13.584. So we'll just round to the nearest tenth. So it looks like 13.6 seconds. Okay. So now we're going to do the same thing. It says using your model from part A. Here's our model. What would be the coast time downtime for a car going 25? So they're asking what's the coast downtime. Remember, that's our Y value. And they've given us the X value because it's in miles per hour. Once again, same thing. You plug the 25 for every place you see x. You plug that into your calculator. Okay, so go ahead and plug that in. And when you do that, you should get 34.2 seconds. Okay, so that's how you use the regression feature to create a quadratic function. Now, I just want us to do a concept summary. So we're going to go ahead and go to our next bit of notes, and let's talk about concept summary. So standard form of a quadratic function. Go ahead, if you know what that is, pause the video and write it down. Okay, let's see if you got it correct. So the standard form is y equals ax squared plus bx plus c. Now let's talk about key features. So first is the vertex. So remember to find the x coordinate. So x coordinate of the vertex. That's where we do h equals opposite of b over 2a. Then we substitute h for x and solve for y to find the y coordinate of the vertex. Okay, remember, if you need to, pause the video if I'm going too fast. So pause the video if you need to get all of this down. Now let's talk about axis of symmetry. That is always, don't forget, always write the equation x equals, and then that's going to be the x value of our vertex, which we use by finding opposite of b over 2a. Now our y-intercept. So remember how we found our y-intercept? We plugged 0 in for x. Another way of thinking of this, it's always going to be 0 and then whatever our c value is for the standard form. Okay, so this is in your standard form. You see c, here's our c here. So whatever that c value is, that's our y-intercept. Okay, so now let's talk about graph. Okay, so the graph of a quadratic function is called a parabola. So remember, we've been talking about that. Okay. And so here they kind of give you the graph, just kind of give you the information of visual. So they have the standard form, 0c, that's your y-intercept. So remember where the graph crosses the y-axis. And then we have the axis of symmetry. So remember, it's a vertical line that passes through the vertex. And so we have vertex here. Okay. Okay, so now what I would like you to do so we can just practice more of the information we have done, please go ahead. We're going to skip the do you understand. We're going to skip those and go to do you know how. So what I would like you guys to go ahead is pause the video and go ahead and try number 1, number 2, and number 3 and the do you know how in your notes. So go ahead and do that for me, please. So this is what you should have gotten for your number 1. So we have a vertex of 228. Here I show my work of how I got the h value. Remember, opposite of b over 2a. And then to find the y, I go and plug my x back into the function for where I see x. And then your y-intercept, remember that is 0c. So our c value here is 40. So we have 0, 40. Okay, let's look at number 2. So once again, you're going to find the vertex and the y-intercept of the quadratic function. So if you've not already done so, pause the video and try that one on your own. Okay, so here's what you should have gone for 2. So my vertex is 211. So remember, you do opposite of b over 2a, so I get positive 2. And then I plug that for where I see x, so make sure it looks like this in your calculator, so you should get 11. Once again, our y-intercept is 0 and the c value. Our c is 7, so it's 0, 7. Okay, let's look at number 3. So will the function below have a maximum or minimum value? And we're going to find that value. So once again, go ahead, if you haven't already done so, do number 3, pause the video to do so. Okay, so here's the answers for number 3. So we should have a maximum for our vertex. Remember, a maximum value refers to vertex. We kind of talked about that quite a bit in our last 2 sections. So our vertex is a maximum because since our A value is negative, we have a -2, the graph's going to open down. And then, so the max value, which is the Y value of the vertex, is 52. Remember how to find that is, I find my X coordinate first, which I got -4, plug it back into the function here. So make sure this is how you plugged it into your calculator. And then you should get 52 as your answer. Okay, so that's the end of these notes here. Make sure if you have any additional questions, email me or come in before, after school, or during interventions. See you guys later.